Hey, what's up, YouTube? This is Mr. O'Connell. We're going to learn a little bit about statistics. You want answers, you're going to get them. This is your study guide for test 5. I call it the whole zero because everything is based on a normal model. So we're going to be using a lot of proportions here. Number one, in the hypothesis test, a sample gives a p-value of 0.056. Which of the following is true? The sample is statistically significant. When I say that, I mean statistically that you reject at alpha 0.10. So think about rejecting. You reject, what this means, you'd reject anything below the threshold at 10. 5.6% is less than that. So yes, it would be statistically significant at alpha 10%. The sample is statistically significant at alpha 1%. It would not be because our 5.6% here is more than your alpha 1%. 3, the probability of getting a sample value as extreme as this one by chance alone, if the null hypothesis is true, is 5.6%. That is NP. For 70% confidence. Although you'd be using the 196. If it was 90, it would be 1645. That all comes from a normal model with, in this case, 70% center, which means you'd have 15% right here. So typing out inverse norm, 15% in the tail, 0 for the mean, 1 for the standard deviation. If you plug all that in, it'll give you your answer. 3, a 90% confidence interval for the difference of two proportions is found to be 33% to 47%. This is a true false each. It is unlikely that the two populations have the same proportion. That's true because if they did have the same proportion, the differences would be 0. 0 is not in that interval. Differences between populations is between 33 and 47. Concentration, true. But now when we change 90% confident to a probability of 90%, the difference between population proportions is between that. We know to that because 90s are confidence, it's not a probability. 4, in a test of null hypothesis, our null is that the population proportion is 0.24 with an alpha 25, and our alternate hypothesis is less than the 24%. A large random sample produces a z-score of negative 1.25. Based on this, what conclusion can be drawn? Well, if you have a z-score, you have to actually find a probability with that. Let me get a calculator page. Get a normal CDF function. So if you draw it out, remember with z-scores, that's in the middle. 1, 2, 5 should be something like this. Oh, that's not a p-hat, that's a z. Hat. Anyways, down here we need to start with a really low number in the shaded region. Oh, need to keep the negative. Up to negative 125. Keep your mean and standard deviation scores. Right about a 10.5% chance. So with our alpha 5, with our alpha at 5, what would our decision be? And that would be failure to reject. Because that p-value is just simply not low enough. If you had a lower z-score of negative 2.5 and you do reject your null, how often do you make a type 1 error? Well, you should know that type 1 errors are going to be associated with alpha value, and in the problem, it states alpha is similar samples. Results in a type 1 error. A 90% or a 95% confidence interval? I always reference the weather. I'm 99% confident that the current temperature outside is between 10 degrees and 80 degrees. It's a really wide interval because I'm so sure. But once I start thinking that I'm only 90% sure that it's in between 40 and 60, that makes it smaller. I lose confidence. So what is wider? 95. And there's a 6, we constructed a 99% confidence interval and wanted our next confidence interval to have a smaller margin without confidence. So if I'm not going to lose any confidence, I cannot change that z. So if you want to go from a large margin to a smaller margin, you're going to take more samples. Think about it like if you really wanted to know what proportion of teenagers like Justin Bieber, I can get a decent idea by asking my class, but if I take a larger sample, I'll just have a better idea of what percent of teenagers like Justin Bieber. A good idea, if I ask my class, I have a much better idea if I ask 12, 15, 20, 100 classes. We made a 90% interval. What is a correct interpretation? We are 90% sample is in the interval. You should cross that out because we know the samples in the interval. We use the sample to make the interval. The interval is the sample p hat plus or minus your margin of error. We're 90% confident that the population proportion is in the interval. That's actually a pretty good interpretation. 90 is your 90 is your confidence, not your probability. And of course, next one talks about the probability of it, which 8, you want a margin of error to be no larger than 5%. Find the sample size necessary. So remember, error z times square root of p hat q hat over n. So 0.05, 95% confidence tells you 196. We use p hat 50, which means q hat over what we don't know n. So 105 divided by that 196. We're left with that would be equal to square root of p hat q hat over n. So it's equal to a square root, so I'll square it. So this number 0.006 is equal to 0.50 times 0.50, which I'll tell you right now is 0.25. And then it's over n here, but an equivalent way to write this would be to have n outside of the equation, so it indicates dividing by that really, really small decimal. So 0.25 divided by, I'll grab that because I have all of these dazzled with it.